Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. Is a reviewer and editorial board member in international journals.
Welcome to the UGC lecture series in computer science. In this series of lectures, we have been looking at a topic, software engineering. In this particular session, I will be discussing on software project management. Saying to the overall contents, I will be letting you know the definition of various terms like project, project manager and other things, and what could be the general questions that will be asked by a customer. The basic difference between two different methodologies which we are about to look at, one called PERT, the other one called critical path method, CPM. PERT stands for program evaluation and review technique, and CPM stands for critical path method. And we will start with how to draw a network analysis diagram, the objectives of a network analysis diagrams and the various notations that have been used. As I have mentioned, we will initially look at the different terms that we quite commonly use in project management. The intention with which we have gone for a project management is every project need to be delivered on time, within budget and with technical specification as specified by the end user. I repeat, it should be every product that is getting developed should be on time, within budget and satisfies all the technical specification that has been mentioned by the end user. First, we will define the term project. Any human undertaking with a clear beginning as well as a clear ending. Any project that requires a clear beginning and what is that has to be conceived at the end need to be clearly given, clearly specified, that is meant to be as a project. A project manager takes up such responsibilities like planning, scheduling and controlling. When we look at project planning, it details the project into a list of activities. Given any specific project, the project that we were considering was a student result management system. This cannot be developed as a bulk. So, this has to be modularized as a module named student result. In fact, within the student result, we will use a term called result data, wherein we will fetch only the student record and we will fetch subject record, we will fetch staff record, by where we were in a position to publish the entire results. So, the output is supposed to be the student result management system, but the input for the system would be these kind of variant data formats. So, we will initially divide these into a list of activities and we will try to estimate the resources that are required for conceiving these activities and time for each activity. Say when we are supposed to get the student details, when are we supposed to get the staff details, when we will be getting the subject details. So, these time also has to be mentioned for every activity to be complete, and the relationship, interrelationship between those activities are also to be mentioned. So, these components make up a complete planning scenario. About scheduling, scheduling represents when a project should start and when will it be complete. Suppose if the customer asks a question of when will you complete this project, you should be able to tell them, if I started at this particular point, I will be able to complete in say 30 weeks of time. So, this scheduling gives you a clear picture of the start and completion time for each activity. Last point is about controlling. This controlling not only mentions the current status information, but also the insight into possible trade off when difficulties arise. In case of certain risk factors, in case of certain delays because of certain reasons, what will be the trade-off when I am about to complete this in 2 or 3 weeks late. At that particular juncture, we will address to controlling. Here are certain general questions which are being asked by every customer. The first question being, when do we expect the project to be complete? So, the approximate completion time for the entire work to be done. If any activity is delayed, what effects will this have on overall completion time of the project? Supposing that I have estimated the project completion time to be 30 weeks from now, if the project is getting delayed by 2 or 3 weeks in between, what impact this would have after the entire completion of the work? The third question is about, if additional funds available, how they should be spent. In case if I am about to give you an additional fund, say how do I utilize it? Either by way of assigning more additional responsibilities, say I could involve more staff members for doing the same amount of work, or I can provide additional features for the same set of projects. And the fourth question being, what is the probability of completing the project by this scheduled date? Looking at the history of this kind of a network analysis plot, before actually getting on to the network analysis, what people suggested was drawing a Gantt chart and a bar chart which helped them to create the entire schedule plan. So, Gantt chart and bar chart has been developed by a person who is called Henry L. Gantt around the year 1900, and Gantt chart is just a graphical representation of the work on a time scale. As a part of operating system, you would have looked into this kind of Gantt charts, where given a sequence of jobs in terms of jobs or batches for a specific duration mentioned, when will it be complete. So, we will work on the waiting time and the turnaround time for calculating the overall duration of the work to be complete. But this kind of Gantt chart plot had some limitations, wherein I was not appropriate in mentioning the term of interrelationship and interdependency, which made a confusing state when the size of the project got higher. That means, as the project size increases, then I might find it difficult to map the interrelationship and the interdependencies between my job. So, for these simple reasons, in 1950s it has been proposed to move in for two other different methodologies, one called PERT, the other one was named CPM. PERT stands for Program Evaluation and Review Technique, and CPM stands for Critical Path Method. This PERT was initially being used with US Navy's submarine missile program, and CPM has been used with planning the construction of chemical plants, and later on, after it was found successful, PERT techniques were being applied to research and development works, whereas CPM has been used for civil construction activities. And out of these two things, we will be able to identify critical paths which are the foundation for drawing the network analysis diagram. The basic difference between use of critical path method and program evaluation and review technique being, PERT is non-repetitive and works well with complex projects in which time estimates are uncertain, whereas for critical path method it is purely repetitive and it could handle only non-complex projects. Now, looking at a term which is called a network analysis diagram. When I say a word of network analysis, it entails a group of techniques for presenting into related to time and resources so as to assist in planning, scheduling and controlling. As far as network analysis diagram is concerned, it is initially to plan, given a list of activities, how they are dependent, what kind of relationship exists among two different activities can be easily gathered. So, it will help the entire work for a exact planning. Then after having mentioned a time of, say I would be able to complete this particular activity in this time, then it would help me for scheduling, and in case of certain risks, how will it be to control it. So, any information including sequence, interdependency and interrelationship, criticality can be easily figured out as part of network analysis diagram. Some of the major objectives of this network analysis diagram being, we could use powerful tools for planning, scheduling and controlling, and this could be very well used for showing a simple interrelationship between activities. Thereby, in case of consideration of a cost, I will be able to minimize the total cost, I will be able to minimize the total time, I will be able to minimizing the cost for a given total time, minimizing the time for a given total cost and minimizing the idle resources, to minimize production delays, interruptions and conflicts. Some of the definitions which I would use as part of this network analysis diagram are, say as I have started with defining a term which is called activity. All projects may be viewed as being composed of operations or tasks called activities, which require the expenditure of time and resources for their accomplishment. Let us consider a scenario of a railway reservation system. For a railway reservation system to be complete, and we request an automated system for a railway reservation platform, in that specific case we might require a detail of login if in case there are different actors who are behaving for the system, say an administrator, a clerk, a ticket reservation person and passengers. So, since 4 different actors are involved for the system, I might require a login which has to be mentioned as an activity. And for reserving tickets, there has to be a list of chart which would mention me the train number and date and scheduled departure and arrival of different destinations. So, that also will be listed as an activity which also will be a part of this particular project. If in case I have to cancel a booked ticket, then that also need to be considered as an activity. So, these represent a list of activities. So, that is how I have given. All projects may be viewed as being composed of operations or tasks called activities, which require the expenditure of time and resources for their accomplishment. And another point that we may have to refer here is predecessor activity. This would be useful when we are about to define the interrelationship or the dependency between the analysis. A predecessor activity is a list of activities that must be completed immediately prior to the start of another activity. If suppose I am to do with say booking of tickets, then I should have done login before. So, that is the kind of understanding which I get as far as predecessor activity is concerned. So, activity thus must be completed immediately prior to the start of another activity are called predecessor activities. And there is another term which has been quite commonly used, which is called successor activity, activity that cannot be started until one or more of other activities are completed. Say I might be able to complete 2 certain tasks, only after completion of these 2 tasks I will be able to start with other activity. So, labeling those kind of activities would be of successor kind, but immediately succeeding them, successor activities need to immediately succeed them, and those are called as successor activities. There can be another happening which is called concurrent activity, activity which can be accomplished concurrently are known as concurrent activities. As far as your Gantt chart is concerned, you would have taken up all the jobs sequentially. Maybe after completion of a particular job which has been labeled A, then only you will be able to do B. Then you can do C. Likewise, you will be proceeding with all the jobs in a sequential fashion. Whereas, when we are concerned with concurrent activities, we could be able to do two or more or one or more even in a parallel way. Let us have a short break here. Welcome back after the break. I was explaining you the different terminologies that we use as part of network analysis diagram. As a part of it, I have been discussing on concurrent activity. This was pretty difficult when I was using a Gantt chart. So, most of my Gantt chart applications would use sequential processing, whereas as part of critical path method or a program evaluation and review technique, I might prefer with parallel operations. So, activities which can be accomplished concurrently or parallelly are supposed to be your concurrent activities. This is how we will represent and notate the different activities that we are mentioning as part of the network analysis diagram. I will start with the definition of event. An event represents a specific accomplishment in the project and takes place at a particular instance of time and does not therefore consume time or resource. An event is generally represented by a notation of a circle. This represents a start of an event and this represents an end of an event. So, as part of the definition which I have given on the top, maybe this here is where I start exactly with what I wanted to do. So, an event represents a specific accomplishment in the project and takes place at a particular instant of time. So, here is the actual instant of time where I start with an activity and here is where I end. So, this is actually the process that I am consuming, but this is the idle start time and this will be the idle end time. Here is where I define on certain other terms which we use it very commonly as part of concurrent drawing. One is called a merge event. When more than one activity comes and joins, that event is called merge event. So, to the specific diagram of this finish, it may not be one activity which is coming and ending here, it may be one or more activity which might end up. Since because it is parallel, more than one activity can also merge at a point. So, that activity is called a merge event. Burst event. When more than one activity leaves an event, that event is called a burst event. So, from this place one or more activity may start, that particular activity will be labeled as burst event. Merge and burst event. An activity may be a merge and a burst event simultaneously, as with respect to some activities it can be a merge event and with respect to some other activities it may be a burst event. Some of the representations that I have told as part of merge, burst and merge and burst are having given here. Supposing that here is the end time of a particular event, here it should have started and this is the start for another activity. When two or more activities merge at a particular point, so this event is called a merge event. As part of the application which I have been mentioning for you, say a student result management system. In that student result management system, for getting a result, I might require student's record and a particular subject's record. With both of these things, I will be able to publish a result. If suppose I am to extract an activity of results, then it includes a subject record and a student record, wherein after merge of these two events properly, I might be able to retrieve result record. Whereas for burst event, at the start of a semester, I might have to do a parallel operation of giving all the subject records and giving all the staff records. Now that I am to decide upon who are the staff who will be handling all these subjects, which comes as the third part of the event record, which becomes at the beginning of the semester. Let us assume the first activity indicates the student record, the second activity indicates the subject record, and the third activity indicates the staff record. So after it is getting merged here, I will be able to clearly indicate in the timetable mentioning these are the staff member who will be handling these subjects, will be listing it for this many number of students, and the same record will go to the result department mentioning who are the faculty members who have handled all these subjects. So at different junctures I might be using different representations, but one common thing which we may have to note is not only sequential activity that can happen in this network analysis diagram, it can also be parallel. When we plot this kind of a network analysis diagram, we may land up in another set of term which is called a dummy activity. Now I will define what a dummy activity stands for. In situations where two or more activities can be performed concurrently, the concept of dummy activity is being considered. Dummy activities consume no time or no resource. Supposing that in this particular situation I have given you a constraint, here is the start of the event and this becomes the end of the event. An activity A is starting at event 6 and getting ended at event 7, and at the same time an activity B is getting started at event 6 and ending at event 8. Now that I do not have any predecessor activity before I start with activity A and B, so I could do these two things parallelly. Whereas when I am mentioning activity D, at that point I might be mentioning a factor which is called a predecessor activity. For starting with D, I would require B to be complete. So I take up B only after the completion of event 8 or activity B. Similarly, I consider C only after completion of activity A. Here I introduce one more dotted line which is also to be considered as an activity. Now this activity is called a dummy activity, that is a dotted line and an arrow mark will indicate a dummy activity, where I would mention to take up an activity of C, my constraint would be something like A should be complete and check to see whether B is also complete, but D can start only with B. So in such circumstances I might use a dotted line and an arrow mark which would indicate me with a dummy variable. So this requires no additional effort and no additional time and no additional resource. Supposing that for a project I would consider in the beginning of the project itself I have given a definition, a project will have a clear start and a clear end. Supposing that the entire of this work is considered to be a project, this cannot be a project at all because it has got two different ends. A project cannot land up in two different products, whereas it should be complete only with one variety. So an event is getting started here and A does its job for some time, after which C gets completed. Likewise B is done parallelly and C is also been conceived after B is complete. But my constraint here says if I am to start with C, I should have completed A and B, but then D could start only after B. So for these reasons I might take this job as a dummy variable. Since it does not have a clear end, this is not mentioned to be a project. This you can correlate with the early discussions that we had, where I would have started defining about the terms which is called unit testing, integration testing, system testing and acceptance testing. Supposing that these are taken as individual activities, A is to be unit tested, B is also supposed to be unit tested, C is another unit, and D is the last unit. So, it has to be individually tested, but after completion of C, both A and C will be integrated. So, that is the kind of relationship which we elucidate from this kind of a network analysis diagram. And likewise, B and D put together would have been tested. So, by where A, B, C, D would be unit tested, and after we pass on to the next stage, it indirectly means A and C put together it will be tested, that we call it as integration testing, and B and D put together it would have been tested, which we again call it as integration testing. When we combine all these 4 activities to a specific node, that means A, B, C, D is completely system tested. So, for these kind of understanding, we start drawing network analysis diagram, which would give us a clear picture of how we have to flow through the entire stage of the project. Further, by drawing this kind of network diagram, we will be able to extract the independent paths that can flow through the completion of project. Say, taking up a path of A and C would lead me to a project completion. It will have a clear start and clear end, but then it is not a completed version of the project which the customers are looking out for. Likewise, B and D can be treated the same way, but that is another flow and it is not the complete stage of a project. So, all A, B, C and D to be complete, so that it leads to a complete version of a finished product. Looking at the summary for this particular session, we have started defining on the term project and what a project manager has to do, and we have started defining on what exactly we mean by software project management, which was planning, scheduling, controlling, and even monitoring can be included. And we have started with analysis of networks, where I have mentioned you with what an activity would mean: a node, predecessor activity, successor activity, concurrent activity, and dummy activities. So, by where to draw a specific network diagram, I would have indicated all these words. Questions: mention the different phases of project management. Why is network analysis required? When do we require a dummy activity? Thank you.